All right, when you're looking at this type of a question, especially any question dealing with ratios, right, and this holds true for any ratios, including when you start prepping for the SAT. Problems or ratio questions on the SAT can be approached using the same strategy I'm going to talk about here. You have one of two choices to work with ratios. You can think of ratios in the relationship between a part to part, or you can think of ratios in terms of the relationship of part to whole. So let me talk about what I mean on this. All right, if you have a linear pair in a ratio of 5 to 1, that means you have 5 parts versus 1 part. Right? If you're thinking in terms of that, you're probably going to use a diagram to illustrate this. And what it means is for every 1 part of x for this lower angle or the smaller angle, the other angle is 5 parts of that same, so the multiplier x, it's 5 parts of that x, so it's 5 times x. Okay, so if you're going to think of this as part to part, you have a 5x and a 1x, you would then add those together to equal the whole, and what's the whole angle going to be in a linear pair? 180, and so then you would solve this for x, you'd get x is equal to 30, and you could plug that back in. So if x is 30, 5 times x is 150. And so you could see, do these have a ratio of 5 to 1? Yeah, you can go back in and it compares in that form. And so that's one way to approach ratios. There's another way that I would encourage you to consider using. It's, in my opinion, more efficient, especially when it comes time for SATs. Being able to think of a ratio in terms of its part to whole relationship can often lead you more directly to the answer. It can be more efficient and quick. All right, if you're thinking in terms of part to whole, you're still looking at the individual parts. Okay, so that's 1 part, that's 1 part, and the whole is going to equal the sum of the parts, like we just talked about, right? Angle addition, segment addition. Okay, so if you're going to compare the part to the whole, what you're winding up doing is you'd see that the larger angle of this linear pair is 5 parts out of how many total parts are in that ratio? 6, right? So 5/6 of the whole thing is equal to the larger angle. Well, what is the whole thing in this example? A linear pair has a whole measure of 180. And so it's just a matter of calculating. 6 goes into 180, 30. 30 times 5 is 150. So you get your answer really efficiently here, and it's representing the exact same thing, except you're thinking in terms of part to whole. So if you look at the smaller one is 1 part out of a total of how many parts? 6. So 1/6 of 180 is going to be the smaller part. Again, 6 goes into 180. 30 times 1 is 30, and you get your solution. All right, so I want you to try example 3 on your own. You can use either of these methods. And you can set it up if you're a visual person or you need to write it out as a diagram. You'll probably want to stick with the part-to-part relationship. However, if you can work part to whole, you'll probably be able to do these type of calculations more quickly. So I would encourage you to try that, see if it works for you. All right, so let's take a look at this. Again, I would probably encourage you, if you can do part to whole, to look at it that way. If you have 7 parts and 2 parts, how many total parts do you have? 9. So the larger one is 7/9 of the whole thing. The whole thing is a linear pair, so it's 180. 9 goes into 180. 20 times 7 is 140. Okay, which means the smaller part is either the difference between that angle and 180, which you're expecting to be 40. And let's calculate it to confirm. So if we do it 2 different ways and get the same answer, we're pretty confident we have the right solution. So the lower or the smaller angle is 2 parts out of the total, which is still 7 plus 2 or 9 of 180. 9 goes into 180. 20 times 2 equals 40. It confirms that we got the right answer. Okay. Now, again, if you want to work visually, you can set it up. Again, the same type of diagram. You have 2 parts to 7 parts. The parts represent there's a common multiplier, which we don't know now, so we'll call it x. And so you know that the sum of those parts has to be equal to the whole. which is 180 in a linear pair, and then you can add them together. Solve for x. And when you do that, you can plug x back in. 2 times 20 is 40. 7 times 20, 140. Hopefully you did notice we do the same exact calculations. It's just a different way of approaching it.